stop me, but I want to make sure I don't leave anything out. So, topic number one, we're going to just back up and do a quick review. Let's suppose that you are going to, trying to think of an example. You're going to get dressed and you're going to wear a shirt, a pair of shorts, and socks. Okay, and you must wear a shirt, shorts, and socks. Okay, no other options. That's what you're wearing. And you have 8 different shirts and 5 different pairs of shorts and 10 different pairs of socks. How many different outfits are possible from your closet here? You remember? You're going to pick a pair or pick a shirt. How many options do you have for a shirt? 8. And then you're going to pick a pair of shorts. How many options do you have? 5. And then you're going to pick a pair of socks. How many options do you have? 10. Now, since you are picking shirt and shorts and socks, and that "and" is important, you're doing shirt and shorts and socks. What do you do with these 3 numbers? Multiply them. So you have 400 different outfits possible. Okay? Now, let's suppose that you are going to, that I give you a slip of paper. Well, actually, I'm going to give you 5 slips of paper. And on those slips of paper are the digits 1, 2, 3, 4, and 7. And I ask you, using these slips of paper, just these slips of paper, how many 1-digit, 2-digit, or 3-digit numbers can you make? Alright, so these are the numbers you're allowed to use. You're going to make a 1-digit number. How many 1-digit numbers how many options do you have? 5, right? It could be a 1, 2, 3, 4, 7, 5. Now what about 2-digit numbers? Now you're going to pick 2 digits from those. So you're going to grab one. How many options for right here? 5. All right, so you grab the 3, not saying put it here. Now how many options do you have for this blank? 4. So how many possible 2-digit numbers are there? 20. So you had 5 possible 1-digit numbers. Now we've got 20 possible 2-digit numbers. What about 3 digits? Well, for the first blank, you have 5. For the second blank, you now have 4, and then you have 3. So there are a total then of 3-digit numbers. There would be a total of 60. Now the question said, how many 1-digit, 2-digit, or 3-digit numbers are possible? So how many altogether do you have here? 85. So what I am trying to remind you is that when you are doing things at the same time, when you are picking a digit and another digit, you multiply. But when you have different scenarios and you want to total them up, then you total them up. You add them. Hello. You need to have your period A and G teachers sign that, and your parent, and get it back to me by Wednesday, okay?
Yep.
All right. Now, let's talk about, he said we talked about repetitions already, but let's do it again. Let's take the letters of the word math. How many ways can these letters be arranged? How many ways to arrange these letters? So think about it. Think about it just like up there. Only instead of having pieces of paper with digits on them, now I have a piece of paper with each of these letters. How many ways could I arrange them?
60, 20, 24.
4 factorial. 24. 4 factorial. Because it's, think about laying them out in a line, it'd be 4, 3, 2, 1, right? 4 factorial. And that's all hunky-dory if we had the word Precal. How many ways could we arrange those letters? 6 factorial. Easy, easy, easy. Until what? You remember?
Mississippi.
Yeah, you run into something like Mississippi, and we already did that one. So let's do committee. That's another one.
Or Tennessee.
Or Tennessee. The word committee. Now, how many letters are there in the word total? Letters in the word? 9. So in general, if I am arranging 4 things, it's 4 factorial. 6 things, it's 6 factorial. 9 things, it's 9 factorial. But these 9 things are different because some of them are the same. So how did we say we were going to handle that if we're arranging things that are the same? Anyone remember? Did anyone take notes? We're going to divide it. And when we divide by duplicates factorial. So there are 2 m's, so we divide by 2 factorial. But there are also 2 t's, so we divide by another 2 factorial. And there are 2 e's, so we divide by another 2 factorial. However many repeats there are, it's that factorial that you divide by. So if I had a word with 3 m's, I would divide by 3 factorial. Okay? Now, caution when I type this into my calculator. Since there's more than one thing in the denominator, make sure that you have it in parentheses. Remember, we talked about where the factorial button is on your calculator. It is in the Math Prob menu. So you go to press Math, click across to Prob, and then the factorial button is down there. Okay? All right. Now, let's talk about having 4 boys and 6 girls, and we're going to ask some different questions here. We're just going to arrange them in a row. We're going to arrange in a circle. We're going to arrange with each gender together. And then we're going to arrange with only boys together. And so that boys must be together. Okay, so we're going to answer these 4 questions. Okay, so here's the given. We got 4 boys and 6 girls. So sit them in a row. How many ways can I arrange 10 kids in a row? 10 factorial. One thing that you cannot forget is, if you are arranging n things in a row, whether it's letters, whether it's numbers, whether it's people, if you are arranging n things in a row, it's n factorial. So 10 people in a row would be 10 factorial. That's the answer, period. Whatever that is, that's some big number. Now, once in a while, kids will do this. That is not right. When do we divide? When they're duplicates, when they're repetition. Now, just because you're both boys, does that mean you're duplicates of each other? No. Because you're in the same category doesn't mean you're identical. We only divide when things are identical. People never get divided. You never divide in a people problem. Letters, sure, M's are M's, they look the same. But boys and boys are not the same. They're different people. So don't ever do that in a people problem. All right, how about a circle? Who remembers that? We talked about that. What happens when we arrange things in a circle? Yes, Charlie, it looks like this. That's right. It would look like that. We arranged it in a circle. How does that change? Does anybody remember? We never talked about that? All right, well, let's talk about it then. When you arrange things in a circle, let me back up. When I arrange things in a circle, so let's say I go down to the cafeteria and I buy a banana, an apple, and a pear, and I put them on my rectangular tray. You sure we didn't do this? Yeah. We didn't? Okay. All right. So how many ways, I buy these 3 pieces of fruit. How many ways can I arrange them in a line on my tray? 3 factorial. No question about it. 3 things, 3 factorial. Well, let's suppose I took, okay, and I could list those. So I'd have my BAP, I'd have my BPA, my APB, my ABP, my PBA, and my PAB. There are the 6 ways that they could be arranged. But let's suppose I took those 6 and I just put them on a circular plate. So BAP, BPA. Now I'm putting them on a circular plate. APB, ABP, All right, so I took those very same 6 arrangements, and you were right. 3 items in a line, 3 factorial, 6. There they are. But take a look at those plates. Now remember, those are circular plates. What do you notice about them? Do you notice anything about them? Some of them are the same. Because with circles, there's really no beginning and an end. With a line, you have a beginning and an end, right? But with a circle, they're kind of continuous. And this plate, and this plate, and this plate are all the same. They're just rotations of each other. Do you see that? Those are all the same plate, just rotated. And what about these guys? They're all the same, just rotated. When you arrange things in a circle, there are fewer ways that are different because you have that rotational factor. There were 3 pieces of fruit. In a line, it was 3 factorial. In a circle, it's just 2 factorial. It's 1 less factorial. So if I had 10 kids in a row, it was 10 factorial. But if I put them in a circle, it's going to be 9 factorial. It is 1 less factorial. I take 7 kids on a camping trip. How many ways can I see them on a lawn? 7 factorial. How many ways can I see them around the campfire? 6 factorial. Those are things you need to know. In general, n things in a line, n factorial. N things in a row, n minus 1. Or n things in a circle, n minus 1 factorial. Okay? So put them in circles, it's 1 less. Now, each gender together. Do you understand what that means? That means the boys all got to sit together and the girls all got to sit together. Okay? which is kind of how you've arranged yourself in here, sort of. All right, so the boys got to sit together and the girls got to sit together. So imagine, here are my 6 girls. They have to stay together. So I'm going to tie an imaginary string around them. So now my girls are together. And then I'm going to tie an imaginary string around my boys, and my boys are together. So when it comes to seating them, how many things am I now arranging? 2. I got a bundle of girls and a bundle of boys. So we start with 2 factorial. That's how many items I'm actually arranging. I tied a string. You guys are all together. So I got this group and I got this group. Now, when I tied those 6 girls together though, when I grouped them together, I could have done that in several ways, right? How many ways can I arrange 6 girls? 6 factorial. So my girls, my bundle of girls, this is how many bundles I have. I have 2 bundles. But my 6 girls can be arranged 6 factorial ways, and my 4 boys can be arranged 4 factorial ways. When we bundle things or group things, we call it bundling. When we bundle or group things, you start with bundles factorial, and then you do individual bundles. So the girls and then the boys. Okay? Now, let's look at this question. I don't care where the girls sit, but the boys have to be together. The boys have got to be together. Okay? Now, think about that for a second. I've tied a string around the boys. So now the boys function as 1. What about the girls? They're still 6. I didn't say they had to sit together. They're free floating. There's 6 of them. So how many things am I really arranging now? Big picture. 7. I'm arranging 7 things. What am I arranging? My 6 girls and my bundle of boys. So I'm going to start with 7 factorial. That is 6 girls and 1 bundle of boys. That's the big picture. But then what do I have to multiply by? 4 factorial. Because when I bundled the boys, there's 4 of them, and they can be done 4 factorial ways. Oh, we having a hard time staying awake. Try. Real hard. All right, let's do another example of that. Let's suppose that we have 5 Republicans, 3 Democrats, and 2 independents. Okay? So we got 5 Republicans, 3 Democrats, 2 independents. You're just going to arrange them in a row. Going to arrange them in a circle. Each tight together. Republicans together. Oh, let's get tricky. A Republican on each end. Okay, all right, so let's do that. Let's do these 6 questions. Here we go. Number 1's easy. How many ways in a row? 10 factorial. How many people you got? 10. Putting them in a row, it's 10 factorial. Stop. Don't do anything else. It's 10 factorial. 10 people in a row. How about a circle? 9 factorial. It's always 1 less. Now, I'm going to seat them in a row, but they got to sit with their own party. So we're going to tie a string around each group. So what do I start with? 3 factorial. Why? Because I'm arranging 3 bundles, right? Let's start with that. big picture, 3 bundles. But then you gotta remember what? Within each bundle, there are arrangements. So how many ways can that bundle be arranged? 5 factorial, and then 3 factorial, and then 2 factorial. So we start with the bundles, and then we multiply by bundle factorial. Now, just the Republicans have to be together. We don't care where anybody else sits, but we need to have the Republicans together. So what does that mean? That means that right there functions as 1. Now what about these? They're 3 and 2. They are not bundled, so they stay individuals. So you've got 2 and 3 and 1. So we'll start with 6 factorial. But because you had a bundle here, you'll multiply by 5 factorial. Now, do we need to multiply by 3 factorial and 2 factorial? No, because we didn't bundle them. All right, let's do 6, because it's the same kind. Only the Democrats together. All right, so that means this functions as 1. So what do I start with? 8 factorial. You've got 5, 6, 7, 8. But because you bundled that, you have to multiply by 3 factorial. Got it? Now, I need a Republican on each end. So I'm going to look at it for a minute. I'm going to draw a picture of it. There are my 10 seats. I got 10 people, 10 seats. I don't care where anybody sits, except that has to be a Republican. All right, now wait a minute. How many Republicans are there? 5. So I have to pick one of them to put in that spot, right? So I'm going to pick one of them to put in that spot. I have 5 options. That does not mean I'm picking 5 people. That means I have 5 options. So I have reached in, grabbed a Republican, plopped him down. Now I need to put one at this end. Now wait a minute. I put one down here. So how many options do I now have? 4. Now, what about these 8 spots?
8, 7, 6.
Exactly, 8 factorial. Isn't that just going to be 8 factorial in there?
Yeah.
Because we don't care there's no restrictions. There's 8 people left, and I have to arrange them. So this is going to be 8, 7, 6, 5, 4, 3, 2, 8 factorial. So the answer would be 5 times 4 times 8 factorial. Got that? Now, I want you to think about something for a minute. Let's suppose that I have 12 people on my math team. I'm going to ask you 2 questions. How many ways can I choose a president, vice president, treasurer? How many ways can I choose a leadership team of 3? Now, I am asking, are you okay here?
I have no idea.
Okay. I am asking, obviously, two questions. My question for you is, are these the same question, just worded differently, or are these describing two separate questions? That's what I want you to think about. I'm going to go ahead and do another couple examples, but I want you to think about that for a minute. And I'm going to call on somebody, and I want to have a legitimate response. All right, so be thoughtful about it. Let's say we have. All right, so first question again. I got 12 people on my math team. I want to know how many ways can I choose a president, vice president, treasurer? How many ways can I choose a leadership team of 3? All right, so what's your thought? Olivia, you are the lucky duck. Do you have a thought on this?
I think it's different because, well, the first one is different positions for different, separate positions, but the thought, the second question is just a group of 3.
Did you understand what she said? She said she thinks they're different, and she's right. And it's different because she didn't use this word, but actually in the first one, the order of choice matters. So for example, if you 3 are going to be the 3 I pick, I can pick president, vice president, treasurer, or president, vice president, treasurer, or whatever, right? And it's different. But if I just pick you 3 and say, okay, you guys lead the team, then whether I pick you first or last doesn't matter. Does that make sense to you? When we are choosing from a group, sometimes order matters and sometimes it doesn't. Would you agree with that? Okay. Here, order matters. Here, order does not. In mathematics, the study of combinatorics, those are distinguished big time. This is called a permutation. If order matters, it's a permutation. And the notation we use for this problem, where there are 12 people, I am choosing 3, and order matters, the notation I would use would be 12P3 or P12, 3. Those mean the same thing. And the calculation for that is 12 factorial over 9 factorial. All right, so I've just given you a big chunk of information. So let me repeat while you're getting this written down. When I have a group of something, it can be anything. It can be shelves. It can be books. It can be people. When I have a group of something and I am picking from that group, where we're headed, by the way, is the study of probability in cards. You have a 52-card deck, and when you deal a hand, you're choosing some from there. That's where we're going with this conversation. But right now I got 12 people and I'm picking 3 of them. If order matters in the choice, it's called a permutation. The notation is either of these, and this is how it's calculated. Now, I think it's pretty clear where the 12 came from. Where did the 9 come from? Actually, that's a great idea, but it's not right. It's not the other number squared. It's the difference. So the permutations of n things r at a time is n factorial over n minus r factorial. That's your formula for permutations. Now get your calculators out, go to where your factorial is, and notice you actually have an NPR button. Do you see it? Go to Math, click across the prob. That's how you get your factorial. You see the NPR button? Everybody see it? Now, how to use it. First, put the 12 in. So you got to put the 12 in first. Then you go back to Math, Prob, NPR. Put the 3 in. And then hit equals. And what does it say? Like 1320 or something like that? So you put in this number. Then you press your NPR button, then you put in this number, and that gives you the number of permutations of 12 objects chosen 3 at a time. All right, we'll do another example here in a minute, but I want to talk about the second one. Because here, I'm doing exactly the same thing. I have 12 people, and I'm picking 3 of them. What's the difference? Order doesn't matter. That is called a combination. No order. The order of choice does not matter. That's called a combination. The notation is the same, except it's a C. And its calculation is exactly the same, except there's an extra 3 factorial. For this problem, there's an extra 3 factorial in the bottom. So it's the total. I'll give you the general formula here. It's n factorial over n minus r factorial, r factorial. And we use combinations when order doesn't matter. So let's evaluate that on our calculator. We do it the same way. Put in 12, and then go to your NCR, and then put in 3, and hit equals. What? You don't need to do it. You don't need to, yeah, I didn't clarify that. If you're doing it by hand, you need to do this. If you're doing that, if you're using the button on your calculator, just put in 12, NCR 3, and it does all the factorial part for you. The button alleviates the need for a formula. You just press the button. What did that one come out to be? 220? Less. Does that make sense to you that there are less if order doesn't matter? Heck yeah. Heck yeah. Order doesn't matter. I'm just grouping. That's the less. All right, let's look at this problem here. I got 10 runners in a race. 10 runners in a race. I want to know how many ways I can award first, second, and third, fourth place ribbons. And I want to know how many relay teams of 4 can I choose. I want the fastest 4 runners on my relay team. I take the top 4 for my relay team. Are these the same problem? No. What's different about them? The first one, order matters. I mean, somebody's going to be first, second. Order matters. So this would be 10P4 because order matters. And this one would be 10C4 because order doesn't matter. I just want the fastest 4, a group of 4. And you could type both of those into your calculator and get answers. I don't happen to know what they are off the top of my head, but you can do that. Okay? So I'm going to give you a problem. I want you to figure it out and get an actual answer on your calculator, okay? Here's the problem. I have a class of 20. So I have 20 students. Somebody left 3 green markers in my mailbox. This is a true story. They were in there. I know they came from. But I'm going to give them to my students. How many ways can I distribute 3 green markers if I have 20 students in my class? How many different ways can I distribute 3 markers, 3 green markers to 20 students in my class? Figure that out for a minute. I'll do the same. We'll compare answers. 20 students. 3 green markers.
Error.
Did you bring a pass in, Sue?
No.
Have you been here the whole time?
Come on, Steve.
Yes, you have.
There you go.
Anybody have an answer?
I don't want to say.
What, Reese?
I got 1,000.
You got it right.
I was right.
1,140 is right. What we typed into our calculator was 20 C3. Now, why did we use C?
Order doesn't matter.
Order doesn't matter. I got 3 green markers. If I give you first, you second, you third, it doesn't matter. You're the group that gets the green markers. All right, let me change something. Suppose I'm giving away a green marker, a red marker, and a blue marker. Same question? No. If the prizes, gifts, are different, red marker, blue marker, green marker, different, then order matters now. Because you getting red and you getting blue is different than you getting blue and you getting red, right? So that one, if I'm giving away 3 different color markers, that one would be 20 P3. Got it? Okay. Apparently last time we were together, we had started in our packet, page 3. Let's go to page 3. I think we're ready now to do this. We're going to do this old quiz. So get your packet out. We're going to page 3 of our packet. Okay, Jeff, you want to get your packet out, please? Everybody has one. Let's get them out. We're to page 3. I can't remember how many we did, but it's not going to hurt us to start over again. So here we go. How many outfits can I make? We're on page 3. It's number 3 at the top. It says 3 with a circle around it. How many outfits can I make with 3 jumpers and 4 shirts? If every shirt can be worn with every jumper. The answer is 12. 3 times 4. I have 3 choices of shirts, 4 choices of jumpers, or vice versa, whatever. Number 2. How many license plates can be made that contain 3 letters followed by 2 digits if no digits can repeat, but the letters can repeat? So I have 3 letters followed by 2 digits, and the digits can't repeat. All right, tell me about this. How many options do I have for my first letter? 26. How about my second letter? 26, because these can repeat. So I can have LL. How about here? 26. 10, 9. There we go. We're going to multiply all that together, and that's the answer to the question. Okay? Try to stay focused now, because you know I'm going to keep on rattling. And you know I'm gonna hold you accountable for it, so please pay attention. Get your mind out of the sand.
We get out right now?
Huh?
We get out Anything we do?
I don't know, I have to check.
We get out
Let me check.
Yeah, we just so we don't know.
We need to check to know when the period ends. Yes, all right.
On my job.
So,
That's all I know.
what you need to do for me, Dan, you need to get your permission slips. You need 3 signatures. Period F, period A, or in period B, period A, and parent. It's 1 point.
Everywhere I went, there's at least like, everywhere I went, there's like a 17-year-old who's smoking a cigarette.
Then you go to math, across the top, down to NPR, okay? Yeah, you gotta put in the first